Welcome to Maths with Paru. In this video, I shall be discussing questions from 2019 January Syllabus B Pearson O-Level examination paper. I've discussed the previous questions in the previous video, so I shall be starting with question 18. This question is on matrices, and they're asking you to find matrix B given that you have A and BA. Now, we can solve equations using matrices where we have BA is equal to another matrix C. And then what we do is we multiply everything on the right hand side by A inverse, because in matrices, the order of multiplication is important. So we have B times A inverse is equal to C times A inverse. Now, A times A inverse is the same as I, which is actually 1. When you multiply I by B, you just get B. So finally, what we end up with is B equals C A inverse. And that's what we need to find out. Now, we have got this matrix C. We're going to call BAC, and we have to find A inverse. To find A inverse, there are a couple of steps. The first thing is we find the determinant of A, which is you multiply minus 2 into 3 minus 4 into 1. When we do that calculation, we end up with 2. That is the determinant of A. In order to find A inverse, we divide by the determinant of A, so that's 1 over minus 2, and then we exchange minus 2 and 3, and we exchange minus 4 and 1, and we have these, minus 2 and 3, and then we change the signs of minus 4 and 1, so we end up with 4 and minus 1. And remember, you have a minus half outside. If you multiply each of the terms by minus half, you end up with these terms. And so now you have A inverse. We know that B is equal to C times A inverse. So we have C, which is 2 minus 8, 1, 2. And we have A inverse, which is, I'm going to write in terms of fractions to make it easier for us. That's minus 3 over 2, minus 2, half, and 1. And then we do the usual matrix multiplication, which is 2 into minus 3 over 2 plus minus 8 into half to get minus 7. 2 into minus 2 plus minus 8 into 1 to get minus 12. 1 into minus 3 over 2 plus 2 into half to get minus half. And 1 into minus 2 plus 2 into 1 to get 0. So this is our final answer for the matrix B. Moving to question 19, here you have a solid cone with a mass of 1,200 grams to two significant figures. So this is about lower bound, upper bound. The moment they say it's to two significant figures. The area of the base of the cone is 38.5 centimeters squared to 1 decimal place. The height of the cone is 5 centimeters to two significant figures. Now, the question they ask is, they have given that us that the density is mass over volume, and they say calculate the upper bound of the density of the cone. Now, how do you find the density of a cone? It's going to be the mass over the volume. To find the upper bound of the density of the cone, the numerator is going to be upper bound, so upper bound of the mass divided by lower bound of the volume. So now we're going to try to see how we're going to work out whatever we need. So upper bound of the mass. Now we've been given that the cone has a mass of 1,200 to two significant figures. Two significant figures is basically, we're looking at 100. 100 because it's 12 to two significant figures. So we take what's left of it, which is 100, and divide by 2, and that's 50. So the upper bound of the mass is going to be 1,200 plus 50, which is 1,250. And that's how we calculate the numerator. Remember, when they say closest to two significant figures, we end up taking the third significant figure. So that would be basically the hundredths term, which we divide by 2. And our bounds are going to be, upper bound will be 1,200 plus 50, lower bound is 1,200 minus 50. So now our numerator is sorted. Let's go to the lower bound volume. If you look at the volume, How do we calculate the volume of a cone? It is the cross-section area into the height divided by 3. That is the volume of a cone. Now, to find the lower bound of the volume of the cone, we have to look at the numerator has to be lower bound and the denominator has to be upper bound. In this case, there is no denominator, so we're only looking at the lower bound of the numerator, which is the lower bound of area times the lower bound of height. Now we have to go individually and find out what is the lower bound of the area and what is the lower bound of the height. Now, we have been given that the area of the cone, the base of the cone, is 38.5 to 1 decimal place. When they say to 1 decimal place, that means we're going to take 0.1 and divide by 2. And because we're talking about the lower bound, it would be subtracting 0.1 divided by 2. So the lower bound area is 38.5. We subtract 0.1 over 2. We end up with 38.45. So that's how we get this answer of 38.45. Now we're going to talk about the lower bound of the height. The height is given as 5.0 to 2 significant figures. So again, we go to we have 0.0, the second significant figure, and that would be 0.1. We divide that by 2, which will give us 0.05. So to find the lower bound of that, it would be 5 minus 0.10 divided by 2, which is 4.95. Now we put that back into this formula that we have. So lower bound of area is 38.45, lower bound of the height is 4.95. We multiply that and divide by 2 to get the lower bound of the volume. Then we put that back in here to get the upper bound of the density, which is 19.7 grams per centimeter cubed. I know it's a little bit complicated, but you have to understand the basics here, which is when we come to upper bound and lower bound, if they say it's nearest to something or closest to measured to this amount, we take that amount and we divide by 2. And then our upper and lower bound would be the original value plus or minus this. And when it comes to a fraction, if we have an upper bound, the numerator is always upper bound and the denominator is lower bound. Those are the things that you have to keep in mind for this question. And this question also comes in additional parts because we have to actually find out the volume. The volume itself has to be found out using a formula, and that too you have to be careful about what bounds to use for that. So this question can be tricky if you don't know your theory, which means my advice is to study your theory. Now let's move on to one more question here, question 20. Here they have given us ABCD, PQRS, similar quadrilaterals, and they've given us lengths. And they've said the side of AD is the longer side of ABCD and the side of PS is the longer side of PQRS. So that means that basically those are the corresponding lengths that we look at. And we've been given the area of the smaller quadrilateral is 10, and we want to show that the area of the larger quadrilateral is some expression. Now we use our basic rules. A1 over A2 equals L1 over L2 squared, and that is for similarity. So A1 over A2, we've been given A1 is 10. We have to find out A2. We write that, and it's equal to the ratio of corresponding sides squared. Now the smallest one, A1 is 2x plus 4 squared, and A2 is, for the larger quadrilateral, it's 4 into x squared minus 4 squared. So I'm going to expand what I have on top. Remember that I can factorize 2x plus 4, and I can write this as 2 into x plus 2. And remember that I'm squaring everything. So then this whole expression, I can factorize it like that, and I'm going to square it. So when I square it, the 2 also is squared, and that is how I get the 4 here. Okay, I get the 4 here because this 2 is squared and I get the 4. And then I write x plus 2 squared as x plus 2 into x plus 2. Okay, so let me just find the color here. Right, so that's how I end up with that. This, I can write this as 4 into x plus 2 squared. Now what happens here is I'm looking at the denominator. If I look at the denominator here, I have 4. In my denominator I have a 4. Now remember that, let me try another color. So I'm going to write this as 4 squared, right? 4 squared, and I have an x squared minus 4 squared. So I have a x squared minus 4 squared. Now remember my 4 squared can be written as 4 into 4, which is 16. But my x squared, I'm going to write my x squared as x plus 2. X squared minus 4 can be written as x plus 2 into x minus 2. Correct? I can write my x squared minus 4 squared. X squared minus 4 can be written as x plus 2 into x minus 2, and don't forget that I have a square over there. So finally, I'm going to write 4 squared as 16, and this whole thing, I'll highlight it for you, which is x plus 2 into x minus 2 squared can be written as x minus 2 into x minus 2 and x plus 2 into x plus 2. Now we do that because we're going to cancel whatever we can. So we can cancel the x plus 2 and x plus 2 with this x plus 2 and x plus 2. We can cancel the 4 and the 16 so that we have got a 4 at the bottom. And so we're going to finally end up with a 4 at the bottom, and we're going to end up with x minus 2 into x minus 2. So that is x minus 2 squared. Now, once we have got that, I write that over here. Alright, and I'm just going to erase, I'll keep that for you. Now I'm just going to cross multiply, where I have 10 into 4. 10 into 4 into x minus 2 squared is equal to a2. So this is very similar to what they want us to show. They want us to show that it's a into x minus b squared. So a is 40 and b is 2. I hope you understood what I was trying to explain to you. That's all for now. Until my next video. Thank you for watching.